Welcome back. In this session, we talk about data leakage risks and AI training exposure. When people interact with AI systems, they often treat them like tools, which are neutral, forgetful, and self contained. In reality, AI systems sit at the intersection of data flows, model behavior, and organizational governance. What is shared within an AI system, how it is processed, and where it may persist all shape a new class of data leakage risk. This section explores how data can leak through AI usage, why training exposure is often misunderstood, and why responsible AI adoption depends as much on data discipline as on model capability. Why AI changes data risk. Traditional software processes data in predictable ways. AI systems behave differently. They accept unstructured input, they generate unstructured output, they operate across vendors and platforms, they blur boundaries between processing and learning. This fluidity makes data handling less visible and harder to control. The risk is not only where data goes, but how it might be reused. What training exposure really means. One of the most common fears around AI is that anything entered into a model will immediately be used to train it. The reality is more nuanced. Training exposure depends on the deployment model, provider policies, configuration choices, and governance controls. However, the uncertainty itself is a risk. If users do not understand how their data is handled, they may disclose information they would otherwise protect. Data disclosure through prompts. Every prompt is a disclosure. When users paste internal documents, financial data, customer information, or proprietary code into an AI system, they create a new copy of that data outside their original control environment. Even if the provider does not train on it, the data may be logged, retained temporarily, accessed for troubleshooting, or subject to breach. The act of sharing is the risk. A common scenario looks like this. An employee copies part of an internal document into an AI system to improve clarity or summarize key points. The intent is efficiency and not sharing. The document is not classified as highly sensitive, so the action feels safe. But the content now exists outside its original environment, processed, stored, and handled under a different set of controls. No alert is triggered, no policy is visibly violated, and yet governance boundaries have already been crossed. Outputs can leak inputs. AI outputs can inadvertently reveal sensitive information. This can happen when prompts include confidential details, they model echo input patterns, and outputs are shared downstream. Once generated, outputs may be copied, emailed, or stored without the same controls as the original data. The leakage pathway extends beyond the model. The problem of context accumulation. AI systems often retain conversational context. This improves usability but increases exposure. Sensitive information shared early in an interaction may influence later responses, even if it is no longer relevant. Users may forget what they disclosed. The system does not. Context persistence amplifies accidental leakage. Why anonymization is not a guarantee. Users sometimes assume that removing obvious identifiers makes data safe. In practice, Re-identification is often possible when data is rich, context is specific, and patterns are unique. AI systems excel at pattern recognition, including patterns that reconstruct identity. Anonymization reduces risk but does not eliminate it. Shadow AI and uncontrolled data flows. Many data leakage incidents do not involve sanctioned AI tools. They involve shadow AI, which is an unsanctioned use of public or consumer AI services. Employees use these tools because they are convenient, powerful, and easy to access. Without guidance, sensitive data migrates into unmanaged environments. This is a governance failure, not user misconduct. Vendor risk and AI service providers. Using AI services introduces third party risk. Organizations must consider data handling policies, retention practices, jurisdictional issues, sub processes, and incident response obligations. AI providers become data processors and sometimes data controllers. This shifts legal and risk responsibilities. AI systems as accidental memory. Even when providers do not train on user data, AI systems can behave as if they remember. They may echo phrasing, they may reproduce structures, or they may reflect rare patterns. This creates the perception and sometimes the reality of data persistence. Trust must be earned through transparency, not assumed. Why sensitive data is especially dangerous? Certain data types carry disproportionate risk, like financial records, personal identifiers, authentication details, or strategic plans. Once disclosed, the damage is difficult to contain. AI systems accelerate exposure by making sharing easy and frictionless. Why data classification matters more with AI? Data classification helps determine what can safely be shared. Without classification, users must guess. AI adoption without clear data rules leads to over-disclosure. Clear boundaries reduce cognitive load and risk simultaneously. Designing safe AI usage. Responsible AI usage requires clear policies on what can be shared, approved tools with defined safeguards, training focused on data risk, not just features, and technical controls that prevent misuse. Security must be built around AI, not bolted on after. Why this matters for cyber risk? AI related data leakage is rarely dramatic. It is incremental. Small disclosures accumulate, copies spread, context persists. Over time, exposure grows quietly until an incident reveals it. Understanding AI data risk helps organizations act before damage occurs. The key takeaways are AI systems change how data flows, persists, and escapes. Data leakage risk arises not only from training exposure, but from the act of sharing itself and from how outputs are reused. Responsible AI adoption depends on disciplined data handling, clear governance, and realistic assumptions about control.